In this video, we'll be learning how to find equations of tangents to curves using differentiation. Now, the first thing to keep in mind here is that all tangents are lines. This means that they have line equations. And as you already know, any line has an equation looking something like this. Y is equal to mx plus p, where m is the gradient, also known as the slope, and I'll put that in parentheses, slope, and p is the y-intercept. And remember, p is equal to the y value at which the line cuts the y-axis. Now, before we look into actually finding tangents to curves, since all tangents are line equations, or rather all tangents are lines, it's quite important to make sure that you know how to find the equation of a line. So for argument's sake, let's just go through a quick example and remind ourselves of the key steps. The first thing we need to find when we look for a line equation is always the gradient. That's m. The second thing we find is the y-intercept, p. The y-intercept, p. Now, maybe I'm stating the obvious when I'm writing this. This may seem a little too easy to you, but it's extremely important to keep those two things in mind. When you're looking for the tangent to a curve, what you're doing is you're looking for a line equation. So the order in which you do things has to stay the same. The first thing you need to find is the gradient of the curve. And the second thing you need to find is the y-intercept of the tangent. So let's go through a quick example. Let's say I give you, or I ask you rather, to find the line with gradient m is equal to 2. And we're told that the line passes through the point 4, 6, which passes through 4, 6. So how will we do this? Well, following what I said above, the first thing we need to do is take care of the gradient. And in this case, we're actually told in the question what the gradient is. We're told right away that the gradient is 2. So we can go ahead and we can write what we already know, that's y is equal to 2x plus p. The second thing we have to take care of, like I said, is the y-intercept. P. And to do this, we're going to use the second bit of information we were given in the question, which was that the line passes through the point 4, 6. So let's see how we use this. We already know that this line has to have an equation looking like y is equal to 2x plus p. But because this line has to pass through the point 4, 6, this tells us that when x equals to 4, y has to equal to 6. And since y has to equal to 6 when x equals to 4, we can replace the x and y values in our line equation to write 6 equals to 2 times 4 plus p. This, of course, leads us to 6 is equal to 8 plus p. And now subtracting 8 from both sides of this equation leads us to negative 2 equals to p. In other words, p is equal to negative 2. And that now leads us to the y-intercept. We're pretty much done now. All we need to do is write this line's full equation. This line's equation is y is equal to 2x minus 2. And we're done. We've just found this line's equation. So keeping that sort of structure in mind, let's move on to the essence of this video, which is finding the equation of a tangent to a curve. Now, I'll just write example here at the top. Let's say we're given the curve y is equal to x squared minus 1, and we're asked to find the tangent to the curve, of course, when x equals to 1. Now, the way we do this is we're going to differentiate this curve's equation. And the reason why we do this is because remember that the derivative of a function can sort of be thought of as a gradient function. In other words, it tells us the gradient of the curve at any value of x we plug into it. So what I'm going to do is I'm going to say we're going to define a function, this curve's function, as f of x equals to x squared minus 1. And to find the slope, which remember was the first thing we had to do, slope or gradient, we're going to have to differentiate that function, which we can go right ahead and say, okay, f dash of x, the derivative, is equal to 2x. But now we're interested in the slope or gradient of this curve when x equals to 1. And the gradient of the curve when x equals to 1 is f dash of 1, which is going to be equal to 2 times 1, which of course is equal to 2. And since by very definition the tangent to the curve has the same slope as the curve at any value of x, we know that the tangent we're looking for has to have a gradient equal to 2. In other words, we can go ahead and say m is equal to 2. And so we already know now that the tangent to this curve when x equals to 1 has to look like this. Y is equal to 2x plus p. So that's sort of like the end of our step 1. And we can box that result just to make it clear. The second thing we have to find, remember, is the Y-intercept. The Y-intercept P. Now, how are we going to find this? In that first example I showed you a few minutes ago, we saw that we were given a point in the question. We were given a point through which the curve passes, and through which the line passes, and that's what we used. Well, in this case, all we were told is that we're looking for the tangent when x equals to 1. But so we need a y-coordinate. And the deal is, when x equals to 1, y has to equal to the height of the curve at x equals to 1, which is given to us by f of 1. Remember, I'll just remind us in blue here, f of x was x squared minus 1. So in this case, at x equals to 1, y will be equal to 1 squared minus 1, which is equal to 0. In other words, we're looking for the tangent to the curve at the point not only at x equals to 1, but at y equals to 0. In other words, we're looking for the tangent to the curve at the point 1, 0. So you may want to jot that down. Right now we have two things. We have y is equal to 2x plus p, and we know that this line has to pass through the point 1, 0. So let's just go to the next page to carry on here. And I'll remind us of that. We had y is equal to 2x plus p, and we know that it passes through the point 1, 0. So what this tells us is that when x equals to 1, y has to equal to 0. And so we can replace the x-coordinate and the y-coordinate in our tangents equation by these two coordinates. And doing that will lead us to 0 is equal to 2 times 1 plus p. In other words, 0 is equal to 2 plus p, which leads us to negative 2 is equal to p. Of course, that's the same thing as writing p is equal to negative 2. And so we've got the y-intercept. And now we can write this tangent's full equation. And we can go ahead and say that this tangent's equation is y is equal to 2x minus 2. And we can box that result again. That's our final answer. And just to make sure that our result is correct, if we look at this, our function's graph, remember our initial curve was y is equal to x squared minus 1. And if we plot that curve on the same grid as the line y is equal to 2x minus 2, then this line should definitely be a tangent to the curve at the point we found, which was 1, 0. And if we do that, that's exactly what we find. And that's shown here. If we look at this curve, we can definitely see here that this curve is y is equal to x squared minus 1, and this line is definitely the line y is equal to 2x minus 2. And most importantly, we can clearly see here that this curve is a tangent, this line, is tangent to this curve at the point 1, 0, since that's the only point at which they touch. We can also see quite clearly here that the blue line has the same slope as that pink curve, which really suggests that we got everything right here. Okay, let's look at another example. Let's say we're given the curve y is equal to ln of x minus 2. And we're asked to find tangent, or the tangent, to this curve at the point e negative 1. Now let's go through this in steps. Step 1 for finding the tangent, and I'll write this, step 1, we need to find the gradient when x equals to e. So how do we do this? Well, to find the gradient, remember, we're going to use this curve's function, we're going to differentiate it, and we'll figure out what that derivative is equal to when x equals to e. So let's go ahead and say we're going to define this function here. F of x is equal to ln of x minus 2. When we differentiate this, this leads us to f dash of x is equal to 1 over x. And we're interested in the point, remember, e negative 1. And at e negative 1, x is equal to e. So at x equals to e, the derivative, which is the same thing as the gradient, is f dash of e, which is equal to 1 over e. So at this stage, we already know that the tangent to this curve at the point e negative 1 has to have a gradient m equal to 1 over e. And I'll just box that result. In other words, at this stage, we can already write y is equal to 1 over e times x plus p. And we can go one step further here and put that x on the numerator and say that y is equal to x over e plus p. That's what we know about the tangent so far. But now we need to find p. And to find p, we're going to use that point we were given in the question. Step 2, find the y-intercept. Find the y-intercept p. So remember, we were told that the curve passes through the point e negative 1, and that we're looking for the tangent to the curve at that point. So that means that this line up here has to pass through that point. And the point was e negative 1. So what this tells us is that when x equals to e, y has to equal to negative 1. And so, using the equation that we have here, and replacing x by e and y by negative 1, we find negative 1 has to equal to e divided by e plus p. And since e divided by e is equal to 1, this leads us to negative 1 is equal to 1 plus p. Now subtracting 1 from each of the sides of this equation leads us to negative 2 is equal to p. In other words, p is equal to negative 2. And we're pretty much done. All we need to say now is this tangent's full equation. And combining the two results that we found in step 1 and step 2, we can now write that this tangent has the equation y is equal to x over e minus 2. And there we have it. That's our final answer. And again, it's worth plotting these two curves, or rather this curve and its tangent, just to see if we got things right. So let's do this here. If we look at both of these curves, we can see that this blue curve here, this corresponds to y is equal to ln of x minus 2. So no problem there. The pink curve, or pink line I should say, is the line y is equal to x over e minus 2. And we can definitely see here that the line and the curve touch at the point that we were interested in, which was e negative 1. And it's quite clear looking at this that at that point both the line and the curve have the same gradient, or same slope. So looking at this graph, we can be quite certain the result we found is correct. And there you have it. We found the tangent to this curve at the point e negative 1.